This is What in the World on Canada Talks, Sirius XM 167.
The great thing about this journey called life is just when you think you've got it figured out, something surprises you. Well, it's rare, especially these days in the year 2015, that we would find something that we didn't know was there in the human body. But that did happen recently. A game-changing discovery in the world of neuroscience that could have game-changing effects on neurological diseases going forward, and who knows what else. Today on What in the World, the discovery, I don't know, of the century? We'll find out. Antoine Louveau joins us today on What in the World, Sirius XM, Canada Talks, channel 167.
Welcome back to What in the World with Richard Garner on Canada Talks, Sirius XM 167.
And welcome back to the show. So yeah, we like to talk about the fascinating, the unexplained, and the underexplained. Well, that's a pretty big category, certainly when you're talking about the world of science, medicine, etc. Too few of us know pretty much anything about anything to do with kind of how we're made, what makes us tick. But we have some general ideas, and one of the sort of general ideas that's out there is certainly in the medical world was that, this 3 pounds that sits on our shoulders called the brain that is central to, pretty much everything that we do was kind of an island, at least when it came to the lymphatic system. And again, I think we get to a point where we kind of believe we know everything there is to know. And then, all of a sudden one day there's a guy looking through a microscope and he's like, wait a sec, what's that? I didn't know that was there. And bam, all of a sudden, not the Twitterverse is a flutter, but at least the scientific Twitterverse is a flutter. And then it sort of hopefully trickles down through shows like ours to the general population of understanding, wow, there was a game-changing discovery made recently in the world of neuroscience that could not only affect huge diseases, especially at a time where we're talking about the aging population going forward, things like Alzheimer's, MS, etc., dementia in general have never been sort of on the front burner in terms of medical issues as much as they have been, as they are right now. So this discovery not only is potentially a game changer, but the timing couldn't be better. Unfortunately, being a generalist myself, this isn't necessarily an area that I would be able to claim expertise in. So I wanted to bring in somebody that would be able to help me. So today, Julia Hamer is joining us, and she is going to be graduating from the University of Toronto as a neuroscience specialist with a major in majoring and is a future medical student. That was terrible. Sorry. She's passionate about the brain. I'm passionate about the brain. We have that in common. Julia has worked on research projects at Baycrest Rotman Research Institute, as well as in the field of medical oncology, evaluative clinical sciences at Sunnybrook Hospital, and a whole bunch of incredible stuff that I can barely pronounce. So before I mess that up anymore, Julia, thanks for joining us. So for somebody like you, and this is, you brought this to my attention because we were talking about, all sorts of cool stuff that's going on in the world. And then you sent me this, revelation, this news a couple of weeks ago. These things don't happen every day. And for somebody like you in your field, what's your first reaction when you read about the work in Virginia with Antoine Louveau and at the Kipnis Lab?
Well, there's two things. I think first off, I was impressed that it was on BuzzFeed.
Yeah,
So,
but that's good, right?
yeah, the world's getting excited, whether it's my science Twitter or everyone else's Twitter. So it's definitely a big discovery. It's not every day that you have an anatomical discovery. Like you said, we think we have the whole body mapped out. Like, we're not going to go and find another spleen anytime soon. So
or I hope not.
I mean, if we do, I'm sure that would make the front page of the New York Times. But yeah, it's definitely huge news.
And even sort of people like in your field, sort of, does this become like I'm trying to think of like, is this sort of neuro geek gossip? Like, does everybody call each other and, oh, did you hear about this?
I told my boyfriend that day I got 7 messages in the morning.
Really?
That it was published. Everyone wanted to know, like, hey, like, what do you think about this? And it actually was discovered in October, but once it takes a while for things to go through the publications, but published in Nature. So Nature is the Vogue of the science world. Like, if you're in Nature, that's big news. So everyone's talking about it, and even the non-scientific friends, like, this is sweet. Like, look at this. Like, the fact that, like, we're now extending this lymphatic system, and just a drawing looks pretty cool.
So let's bring in the person that was really on the other end of that microscope, who I don't know, I'm guessing went to work one day thinking it was maybe going to be like any other day at work, and then all of a sudden you saw something that wasn't supposed to be there. So we welcome from the Kipnis Lab in Virginia at the University of Virginia, Antoine Louveau. Antoine, how are you?
Good, thank you. How are you?
Good. How has your, I don't know, last 3 weeks been since the article came out in Nature?
They've been pretty crazy.
Yeah. Now, what is crazy for you, versus, let's say a semi-anonymous researcher one day to, doing interviews at the New York Times and all these other publications around the world? How is that transition?
That was pretty unexpected, and it's something we're absolutely not prepared of. At least I wasn't.
So speaking of not prepared, so we obviously have to sort of go through, and Julia's going to help me here, be able to translate this for our audience. But first of all, let's start with this. It's a game-changing discovery. And as Julia touched on, it's unique in that it isn't just understanding something better. That happens. It does happen, and that's usually very important. But in this case, literally an anatomical discovery inside the human body that we were pretty confident there was nothing left to find. So give us sort of a bit of a play-by-play. You go in like any other day at work. I don't know, you grab your coffee, you set up, and then you're looking into a microscope, and all of a sudden, what happens when you're like, wait a sec, what is that?
So as you said, so when we first did the staining to see if the structure we saw was a lymphatic vessel, we started by doing that more as a negative control, like it wasn't supposed to be there, but let's just check. But when we saw the image on the microscope and we saw those vessels that were looking exactly like vessels, we said, whoa, that was unexpected. And then within seconds, the idea was somebody must have seen that before. There's no way that's new. And we just thought that we just didn't know about it. But so we kept on working on it, and we went through the literature, and no, this is something that nobody saw that way, and nobody characterized it, and so this was something completely new.
Definitely something new. So just to sort of give our audience a bit of an idea of what he was looking at. So when he saw vessels, well, one, it could be just a cardiovascular vessel, so a blood vessel, but you guys checked for that. Definitely wasn't a blood vessel. So what they test for was a specific stain called LEC, so it's like lymphatic endothelial, I believe, cells. And it tested positive for that, if I'm correct. And
so from that perspective, you'd have to be testing for that specifically, wouldn't you?
Oh yeah, it's a very specific stain. So the fact that they, like you said, well, we might as well try, I guess, to see if it's there.
So why are you guys looking at it? Like you said, it's one of these weird things you do in science that you think something's there, but you got to prove it isn't there. Why were you guys specifically going down this particular path?
So the question we had when we started that project was, we know there are immune cells in the surrounding of the brain called the meninges. And our question was, if their cells are there, they must be going there and leaving that area. And so that was our main question. And when we looked at those immune cells in the meninges, we saw that some of them were into a vascular structure that wasn't a blood vessel. So the second, the thing was, then the second vascular system of the body is the lymphatic system. So it's not supposed to be there, but let's make sure that it isn't a lymphatic vessel.
So let's back up on that for people at home, because again, obviously we're jumping ahead, we're excited, but maybe a basic explanation. I'll start first with you, Antoine, and then Julia, you can expand on this as well. But what is the lymphatic system? I guess, why is it important, and what does it do?
So it has the lymphatic vasculature has two main functions. The first one is drainage of fluid from the tissue, and that's going to enable a cleaning of the tissue and not accumulation of bad thing into the tissue. And the second major role of the lymphatic vasculature is to help the immune system build a response. Like the perfect example, like when you cut your finger, then you will have bacteria entering your wound. And those bacteria and the immune cells that are next to the wound are going to use the lymphatic vasculature to go back into the draining lymph node so that it can get activated, and they're going to fight the pathogen that's in your finger. So those are the two main functions of the lymphatic vasculature.
So Julia, you're at school at this point, obviously, and been studying this for X amount of years. So it's pretty indisputed that there is no connection between the brain and the immune system, which really guides how we look at disease, how things happen and whatever. So from that perspective, at least for somebody in your field and your professors and whatever, how does this change how you look at things? Because I'm guessing, obviously we're going to talk about some of the applications, but just this idea that there actually might be a connection between the immune system and the brain, how does that change your world?
Well, usually at the end of any paper that we write or that I even read, there's always a lot of question marks, like, well, it could be this. Like, no science is going to be like, maybe there could be lymphatic vessels. So those question marks and all those possible theories are now going to be looked at, which is incredibly interesting, especially for the field of neuroscience in terms of what we were talking about earlier, Alzheimer's disease, that it has to do with that propensity for amyloid plaque, which is a pathological protein in your brain that builds up. So usually in a normal human brain, so a non-Alzheimer's patient, protein builds up over the day and then it dissipates at night. But someone that has that disease, it builds up and it builds up and it doesn't clear. So again, like Antoine said, the lymphatic system has to do major clearance of all the other tissues in the body. But now that we know that it's in the connective tissue of the brain, so your meninges, perhaps it has some clearance pathways from the brain into outside of our central nervous system and into the periphery.
Perfect segue to our next segment when we come back with Antoine, because of course I'm sure, Antoine, just like everybody else, people want to know how does this affect me? What are the potential applications? And in this particular case, they're quite huge. So back with more with Antoine Louveau on the other side of the break. It is What in the World, Sirius XM, Canada Talks, channel 167.
Don't you know, they're talking about a revolution sounds.
You're listening to What in the World with Richard Garner on Canada Talks, Sirius XM 167.
And welcome back. We're talking scientific discovery and then some today with our guest, Antoine Louveau, a postdoctoral researcher from the University of Virginia. Go Cavs, Kipnis Lab, and really has been in a whirlwind since making a major discovery. Again, as Julia talked about, our co-host today, Julia Hamer. This was actually October, but with the scientific process, which we're going to get to a little later, by the way. Obviously you have to sort of make sure you saw what you saw, and then it has to get published, et cetera. So published in June in Nature magazine, and this was something that really got coverage everywhere. It wasn't just in scientific literature. It certainly transcended even news and sort of news and science sections of, let's say, CNN and New York Times, to Julia's point earlier, on BuzzFeed. Like, that's really huge. That tells you that this is a transcendent discovery. But before we get to the let's say, exciting stuff, Antoine, in terms of applications and what this can mean going forward, just bring us up to speed. This was done on a mouse brain, I'm guessing. Where does the sort of the double checking on human brain, where does that stand? When do you know that this is definitively the same results you would get in a human brain?
So, like you said, the story we just published has been realized in 99% in mouse brain. And we published a couple of hints based on human sample that we had at the time that similar structure might be present in the human meninges. But this is something we are actually working on right now in the lab to really confirm that those structures also exist in human, because that's going to be the major step to see if what we discover can actually be translated into human diseases.
So touching upon human diseases, where do you think this research will be most translational? So I talked a bit about Alzheimer's disease. I know in your paper, I think you might have mentioned a bit about multiple sclerosis. So who do you think is going to be affected most by this discovery?
So the way we think about it is that every neurological disease that has an immune component, which is most of them, we're going to have to check how those vessels play a role or might play a role in those diseases. And so, as you said, Alzheimer and multiple sclerosis are the first one that comes to mind. But if you think about autism, it also has a strong immunological correlation, and those vessels might play a role there. If you think about lymphedema, which is a disease of the lymphatic system, some of those patients do present neurological impairments that we so far were not very able to explain, and so maybe those vessels are the one causing those neurological impairment in lymphedema patients. So we think that those vessels might play a role in a very broad number of diseases.
And the interesting thing about research, as we know, it's driven by driven by necessity to a degree, right? I mean, obviously, if there's a real appetite within the world at large to get to the bottom of something, you're going to have an easier time getting your research funded. In this case, we talked a little bit earlier, one of the biggest priorities and biggest medical issues going forward is obviously the talk about the aging population, the baby boomers, et cetera. So this particular area of Alzheimer's, dementia, and degenerative brain diseases has been, talked about more than it's ever been talked about before. So I'm curious, when you guys publish something like this, how does the process go forward for the research to expand? For first of all, I'm sure you apply for grants and all of those things, but do people come to you? Has there been any sort of reaching out from different sectors or different entities to say, okay, we want to give you guys X amount of money to get to the bottom of this problem?
So right now we mostly have been contacted by patients that are interested in knowing how that discovery is going to help. Right now we haven't been in touch with people that want directly to give us money, but we're hoping that the fact that this story is in the news, that's going to provide us money so that we're going to be able to work on those diseases.
What's the most important follow-up research for you right now, outside of obviously, like you said, a little more confirmation that it's in the human brain and it's the same as whatever. But if you had your ideal situation going forward, what would you do next?
So we are actually already working on the next step, because as you mentioned, the paper just came out, but the story was already there for a couple of months already. So we are actively working on right now in the lab on the function of those vessels in multiple sclerosis, in Alzheimer, and we're starting projects on meningitis.
Have you been able to show the linkage to the cervical lymph nodes? Like, is it actually being drained from this? Yeah, sorry, continue.
We've showed right now we're still working on having a really nice way of showing that, but there was a paper that just recently got published in Journal of Experimental Medicine that showed really similar result to what we showed, and they show also connection to the deep cervical lymph node. And so that was very good for us, because that's an independent lab confirmed our finding, which is confirmation of findings is a pretty important thing in science, especially nowadays. So we are fairly confident about that physical connection between the meningeal lymphatic and the cervical lymph nodes.
What did they think before, Antoine, was happening? Because although there wasn't a physiological or physical connection that was at least that we were aware of between the immune system and the brain, there were things that kind of went back and forth in that realm, with, I guess, a lot of question marks. And obviously, I'm sure there was a lot of theory around how does, sort of this get to that. What was the general thinking before this sort of game-changing perspective?
So, as you said, we knew that the cerebrospinal fluid was able to leave the brain because there were studies conducted in the 1970s when they injected colored tracer into the CSF of animals, and they could see those tracer ended up in the cervical lymph node. So we know there was a way for the CSF to get out. And so the accepted path so far for the connection between the cerebrospinal fluid and the deep cervical lymph node was through a structure called the cribriform plate that's localized next to the olfactory bulb. And that was the accepted path so far. But our discovery show that at least if it's not the only path, there's at least another path possible for the connection between the cerebrospinal fluid and the deep cervical lymph node.
Just to give a little translation there on cribriform plate, I got a look from Richard. Basically, just our audience, we're talking about a part of the brain that's to do with smell. So that's your sense of your olfaction. But yeah, that discovery was there. But again, with science, unfortunately, you can prove something in one lab. But like Antoine said, the paper that was just published, which I read last night, you have to repeat science over and over again to really have it confirmed. So definitely a cool discovery there.
Well, we'll get to that a little more too, because I want to talk about this in broader terms, Antoine. Not just what this does in terms of the very important area of neurological diseases and this incredibly important organ we have on top of our shoulders, which for a lot of us we feel drives mostly everything to do with the human body going forward. So that you can't overstate how important this is. But I'm also curious how this hopefully maybe that this might affect some other areas of science in general, especially when we're talking about this belief that we got things figured out and we're constantly surprised and with new information and new discoveries. But before we get to that in the next segment, I just want to find out from you personally, like, what were your aspirations as a scientist? Obviously, you go into something like this, you want to do things that are going to positively affect the world. But, when you're growing up and then studying ultimately to get into the field that you are, this is obviously sort of top of the mountain type stuff. Where does this sort of rank with what your aspirations were in terms of a young budding scientist?
So my long interest is the interaction there is between the immune system and the brain. And they have, I think in all levels, you can see similar thing in the immune system and in the brain, the way they function, the way they develop. And in adults, we know they communicate. And I was always interested in this interaction between those two systems that for decades everybody thought that they were completely independent, that the immune system never reached the brain because if they do, that's something bad. And now we're realizing that the immune system is there in the brain, in normal function, in normal brain, and it's important for the normal brain function. And I'm always got interested in that. And the meninges are the perfect interface between those two systems. So that's why I was, and I'm still, very interested in the meninges and what they do and what's happening there. So that got along to that discovery.
Yeah, and I mean, again, you can't even somebody that doesn't, is a layman in this particular area like myself, just understanding that if you don't think there's a connection between the immune system and the brain, the immune system, again, even to the person on the street, you understand that the immune system protects us, it helps us fight disease, et cetera, in our body. And if you believe this incredibly important part of the body was, no pun intended here, immune from the immune system, that it had this sort of, it was on this island unto itself, then of course you don't even know where to start with looking at a way to potentially deal with a lot of these neurological diseases. But I got to imagine that this opens up so many different avenues in terms of research around these, which we've touched on before. So we're going to take a break. We're going to come back with Antoine. We're going to talk a little more about the scientific process in general, how it works for people that don't understand it, and how it maybe could work better so these innovations and breakthroughs aren't as rare as they seem to be these days. It is What in the World, Sirius XM Canada Talks, Channel 167.
Faces, bright and early for the daily races, going nowhere, going nowhere.
This is What in the World on Canada Talks, Sirius XM 167.
And welcome back to the show. In studio with me, Julia Hamer, helping me and you decipher a really, really important scientific discovery. And the person that was on the other end of that microscope, Antoine Louveau, joining us from the University of Virginia, Kipnis Lab. If you haven't read about this, go out and Google it, because it's really important when, again, specifically talking about the incredible possibilities when sort of applying this knowledge and perspective to the study of neurological diseases, the ones we're familiar with, Alzheimer's, degenerative diseases. But Antoine talked earlier, I mean, you're talking about autism being affected by this. Julia mentioned MS. I mean, probably we sit down long enough, we could probably make a list of about, who knows how many things. So again, impossible to overstate the importance of this, specifically and directly related to the things that are important to people, our health long term, especially our brain health. But one of the things that stood out to me, Antoine, that I think is, I don't know about as important, but I could make a case that it is, and something that it doesn't get talked about enough for as often as it happens. But it's amazing to me that we can be so absolute and definitive in what we believe we know, right? And of course, we're dealing with the most recent information we have, but so often we're guilty of just driving a flag into the ground and saying we got all this figured out. And my opinion on that is that that lack of open mind, the arrogance, really, I mean, for lack of a better word, that becomes a variable in the research process itself, and a negative variable. And in this particular case, obviously you guys were, again, no pun intended, you're kind of immune to that because you were saying, no, we're looking for, even though it's not there, we think there might be a connection. We're going to continue to look, and lo and behold, this sort of, hallelujah moment where you find something that we've been saying in textbooks for, anatomy textbooks, et cetera, forever, or for, the last X amount of decades, that there just is definitively, indisputably no connection between the immune system and the brain. And bam, this discovery changes that. And again, we could sit here all day and talk about the amount of times that we thought we knew everything, and then we discover things that totally change the game. How often, first of all, is this discussed in the world? Like when you go to conferences, does anybody ever say, we're having a symposium separately today about ego, or about arrogance, or about open-mindedness? Because my opinion is that I'm guessing that the amount of breakthroughs and innovations that could happen in the world of science, if you were able to subtract the belief that we know everything, would probably be exponentially greater. Do you understand where I'm going here?
Yes, I do. So I think the problem is that in science we will never have definitive response. And I think that we need to realize that whatever the scientific community is publishing is that this is the extent of our knowledge at one time, and with the extent of the techniques we have available, with the thing we already know. And we know that some laboratories, as you mentioned, find different findings when they're studying the same subject. And because we work in facilities, and the different facilities might be working somehow differently, and that's why the results are going to be different. So I think that the science we're doing is never going to be the final answer. It's always raising another question, and it needs to be validated by other people, and it's always a work in progress. So I see your point by saying that there are some problems of arrogance or ego in science, but it's always something that's on the move, and there's always people that are going to think outside of the box, and they're going to try to find something new, and they're going to keep going.
But the crazy thing about that, Antoine, that and it's so true, is that those people are always attacked. Like, don't you find, and attack might be the stronger word here, but like you have to almost go through a process. If you introduce something new into the scientific world, and you tell me honestly, if you're on a lie detector right now, what's the general response from other researchers immediately? If you come in with something really bold and really outside of the box, what's the general response out of the gate from everyone else?
So I agree with you. You're going to have a lot of skepticism at the beginning, but that's why we keep on gathering a huge amount of evidence to further prove. For example, in our story, the first staining we did that gave us that result that we saw those vessels, we could have said we found lymphatic in the brain, but we had to gather more evidence and do a functional characterization and stuff like that to further prove people that what we were saying was true. And I think that if you come with a decent amount of proof of what you are saying or suggesting, then people in the science community are going to accept more what you're saying.
And Julia, I know we've talked about this multiple times, and again, I remember grade 9 biology and whatever chemistry and learning what the sort of the scientific process was a little bit. You're obviously in this field a believer in what Antoine is saying, that there's sort of checks and balances there that are going to prevent somebody just there's a smudge on the thing and somebody's announcing they cured cancer. I get that, right? That there's an importance of checking and double checking and triple checking, et cetera. But sort of give the people at home, first of all, a bit of a refresher on the scientific process, and then let's just talk about whether maybe we could tweak the scientific process today on the show and perhaps also cause a ripple effect going forward and save the world.
Just a small goal.
Just that.
Tiny goals. Just a Friday goal. Well, the beautiful thing about nature, like the journal that Antoine just published in is how thorough their experiments are. So there's high impact journals and there's low impact journals, and Nature is the highest impact because of the quality of experiments that they do. So not only do they test like, hey, this looks like epithelial cells, it's not this, it's not this, it's not this. If I put it in a red box, it's still going to be epithelial cells. If I put it in a blue box, it's still going to be epithelial cells. And if I throw it across the world, it's still going to be that. So it definitely takes time to prove it because everyone's going to have a different variable or different bias, and they're going to try and nitpick at different things. But you have to go through all those little steps if you want it to be validated. And having that second paper that was just published in June 2015, so it just came out probably a couple of days ago, that it repeated their experiment and also found similar results and added to it. Now that just strengthens it like tenfold. So the more papers that are published and the more times that you cite that journal, it's just going to expand upon that true belief. And
So you're happy with the level of rigor at this point? You think it's important that that essentially this is how things should be?
it's frustrating the pace sometimes, but depending on what it is, I mean, doing a couple more stains isn't going to take your entire life. But in terms of other scientific processes, so in terms of, getting a drug out there, so any sort of therapeutic target, going through, phase 1, phase 2 trials, phase 3, those do take a tedious amount of time. So it can be frustrating when you do think you have like that golden egg and you want it to go through phase 3 faster. It still has to go through those 6-week trials and whatnot. But until someone finds an alternative solution, we're kind of stuck in that concrete framework. So I don't have an answer for that, so I'll have to take that and run for a bit.
Well, yeah, we'll try to solve that on another show. But Antoine, and you understand what I'm saying, and obviously you're a scientist here, and again, you're going to err on the side of caution. I mean, it makes complete sense. You're talking about, especially whether it be medical or really important things that affect the world. But is it also possible, and I'm talking about degrees here, I'm not talking about black or white or one or the other. I'm talking about is it possible, and are there people in the scientific community looking at tweaking the scientific process that exists right now to potentially, because, I had somebody on talking about neuroplasticity a couple of shows ago, and the real initial stuff in that was like 1920s, and it took 50 years for it to really be recognized. And it just feels to me that maybe we're slowing down our own evolution at times because of the rigor around that sometimes maybe slows up innovation and breakthroughs.
No, I see your point. I think that a lot of things is that we need the technology. Like, for example, when you cite neuroplasticity, I'm pretty sure that in the 1920s, the studies were there, and maybe what they were showing was neuroplasticity, but we were lacking the tools to fairly prove that and prove that it was not something else. And I think that's why, in some cases, science is going to take years to accept a phenomenon that has been observed very early on. But I think the matter of caution is important. Like, we don't want a study to prove, like you said, that we cured cancer, and within a week we're going to see that wasn't true. So I think we need that process. We know it's slow, and we're trying to make it go faster, but I think the review process, the confirmation process is very, very important.
Yeah, and agreed. And, I wouldn't equate this to the sort of the normal, like it's the microwave culture and I want it now. But it seems to me that sometimes you worry that, maybe things are happening at a glacial pace instead of a little quicker. And obviously when you're talking about lives hanging in the balance, everything should always be innovating, right? I think we'd agree with that. And it seems certain institutions, are kind of out there on their own and don't get looked at and don't get revised. But again, that's just my opinion. We're going to finish up with Antoine on the other side of the break and come back for our last segment. It is What in the World, Sirius XM, Canada Talks, channel 167.
Welcome back to What in the World with Richard Garner on Canada Talks, Sirius XM 167.
And welcome back to the show. Today we're talking about an incredibly significant breakthrough and discovery in the world of neuroscience. Again, October 2014 really is where the sort of main aha eureka moment happens, and recently published in the journal Nature, which created a real ripple across the world. Essentially, Antoine Louveau and his group at Kipnis Lab at University of Virginia find, I don't know about the elusive, but there were other people that had suggested this could be possible, but certainly most people believed it wasn't a possible or a possibility. And in this case, you guys find this connection between the immune system, the lymphatic system, and the brain, which is a game changer and something historically, I believe, will be talked about for many, many decades to come, in terms of this being an inflection point in our understanding of the most important part of our body, arguably, and how that's going to affect us going forward. Now, outside of that, Antoine, and obviously as part of what we're doing here today, Julie and I have talked a lot about, the idea of communications in science. And another thing that because again, I'm, like I said, I'm a generalist, but I have a real interest in all things science, all things, significant and important to our day-to-day existence, individually and collectively. But I think we'd all agree that too many people don't have that interest. And that's not something I'm projecting onto people or making the argument, oh, everybody's just stupid and vacuous and super. Well, if they are, it's because that's the society we've created. And this idea that, well, science, let's leave that up to the scientists, let's leave that up to the smart guys over there, because we're all too dumb to understand that stuff and whatever. And here we are in this age of information that's turned all of that upside down, where anybody can go and really do deep dives into stuff, and of course have to disseminate between, different information, etc. But I saw a documentary earlier this year, and it really struck me how important this was. It was called The Merchants of Doubt, and it was specifically about climate change. But essentially what the premise was that, initially when, the real sort of first phase of climate change understanding, Inconvenient Truth, Al Gore, etc., everybody's getting it, everybody's on board. But the last 5 to 7 years has seen a real shift in a lot of denying, and it's been reflected in government policy. And the scientists that were featured in this documentary essentially came to the conclusion that the reason why this shift had happened was because they, and just, generally speaking, the community itself, had underestimated the importance of communications. They thought, look, this information is super important. People will understand this. It's talking about our future and our survival. How could anybody not get it? Yet then they found that the people whose interests were not served by massive policy and reform that would affect, business, etc., were going to come out and do everything they could on the CNNs and the Fox Newses of the world to make sure and bring doubt into the debate, because they were better at being able to communicate and essentially scare people. My point is there a shift in the scientific community, let's say when discoveries like this happen, where there's a bigger understanding now that we need to be better and more and prioritize it more to be able to create a bridge to make science more accessible for the average person?
So I think that the main thing is that as scientists, we are not trained, and that's not a usual habit for us to present our data to general audience. We are really used to present data to other scientists. And when it comes to explain what we're doing to a general audience, that's something we're not trained to do, and we might sometimes be bad at it. And I I agree with you that there might be something to do in having maybe people that are trained to being able to translate what's happening in the science world and translate it for the general audience so that people know what science is doing and how what science is doing is going to be relevant for their everyday life.
Basically, we need a million Bill Nyes in the world just to give us a little information on what's happening in the science world. I know in my classes, my professors always try to stress that now is being able to communicate. But again, when I'm giving a presentation to a classroom full of other scientists, I'm not exactly explaining what the lymphatic system is. I'm just going on into details more about the Dura matter, XYZ. So there's definitely a gap there, but
we've almost solved it. See, I told you we'd have a big solution today because, again, and I think you and I touched on this a little bit before, Julia, but I'm curious, Antoine, whether this is even being discussed. You know, you're currently at the University of Virginia. Julia, you're at the University of Toronto. You're obviously within the sciences. Do you currently have, as part of your curriculum at the University of Toronto, a science or communication of science course?
Oh, absolutely not.
Antoine?
No, I mean, I'm more later in I don't have classes anymore, but no, I never had any training doing that.
Because that seems like the logical place to start, because you've both touched on the main issue, which is the only importance of communication for you guys is to be able to convince other scientists who are already at a very high level. But because the reason why I think this is so important, Antoine, is that this type, like, I can't tell you how many times I read about something like this, and then it's sent to me or it's shared on social media, but I'll go to a general news site and it's not even in the top 10 news stories. It's not on the 6 o'clock news. You can find it. This was an exception, actually, which speaks to how significant your work and this discovery was, because like Julia said, it was on BuzzFeed. Like, that's big. But there's a lot of big things, and I'm just curious whether, going forward, because we're seeing a little more, Neil deGrasse Tyson with Cosmos that comes back. There's some sites around science. Julia mentioned Bill Nye back in the day, but I would think that, yes, there's a trickle-down effect when you make a discovery and it'll get to where it needs to be. But with so many things and so much government policy being affected by what the average person thinks, how important is it to you going forward that, that people, that there is an accessibility, I guess, to the work that you do? Is that something, I guess, that you guys think about or talk about?
That's a tricky question. I'm not sure in our everyday life we think about the science we're doing in terms of communicating to a general audience. And I think that it's also because our study, the main finding is easy to translate to a general audience. But if you take some other studies where they studied interaction between two specific molecules into a disease, this is something that's going to be way harder to explain and to see the direct effect that result is going to have to the general audience on their everyday life. So I think it's definitely something we need to work on, but it's definitely something that's also hard, because also the difference that in science you cannot overstate. You can only say what your result is showing. And I feel like when we explain stuff to the general audience, sometimes we might be entitled to overstate our findings. And I think that can be highly misleading.
Yeah, interesting.
It's definitely a lot of misleading information. Speaking of BuzzFeed, I mean, your case is a lot different in terms of, like you said, it's very easy for the general public to understand. You give a photo of what the lymphatic system looked like before and what it looks like after. They can see a nice pictorial representation. But in terms of any other findings, I know on BuzzFeed they had one that said drinking red wine is equal to exercising for an hour. And that got tweeted and reposted and shared like a million times within like an hour. And I go back to the original article. That does not translate at all. But then I guess whoever's working at BuzzFeed, if they don't have a science background, able to understand what that molecule is and how it affects the brain, it's not equal to exercise. But unfortunately, there is that communication gap. Like I said, whether you're not communicating at all or miscommunicating it. And at the end of the day, I think miscommunicating is a lot worse than just not knowing at all.
Yeah, that's a red flag. I think you see red wine. Well, hopefully you guys are able to celebrate Antoine. I know that, like you said, there's a lot of work to do going forward. But, you know, I think it's clear that, you know, history is going to look back at this particular discovery as like we said earlier, a real inflection point that could open up all sorts of different doors that are going to save lives. Like, I mean, let's not, sort of gloss over that fact. This could not just save lives, but save quality of lives for so many families that deal with different neurological diseases and so many other things, and who knows what. But I mean, from that standpoint, I guess congratulations from all of us here, and continue to do the work that you're doing, and thanks for joining us today on the show.
Sure, my pleasure.
Okay, that is Antoine Louveau from the Kipnis Lab at University of Virginia. And, again, just sort of before we sign off, we got about a minute left. We've talked about, the real sort of real world applications. But Julia, at the end of the day, can we overstate how significant this discovery is?
I mean, right now, there's a few papers that, I know there's tons of labs that are working on it. So, yes, it could be a huge change, or it could be very small. I mean, personally, from my own belief, I think it's going to make a big difference in terms of therapeutic targets and drug delivery, but you just don't know. We got to go through that scientific process, and like we talked about, it's not fast, so don't hold your breath right now. Well,
unfortunately, this show is fast, so we're at a time. But anything new that we find out about this, we'll certainly update you. We'd like to thank our guest Antoine Louveau for joining us today. Julia Hamer, thanks for coming in and doing a bang up job of translating for our audience and for me. Join us next week. It is What in the World, Sirius XM, channel 167, Canada Talks. Yeah, we just signed off, so you can just add it. What was that all?